Hello students, how are you all? Welcome to Chemistry C World. Today we are going to be discuss about oxidation number. Do you know what I mean by oxidation number? Oxidation is nothing but charge present on the atom, whether it is real or imaginary. So, charge present on the atom, charge present on the atom, whether it is real or imaginary. Let me go with it. What is mean by real? What is mean by imaginary? See that here we have example sodium plus. Sodium plus is nothing but sodium ion. In this we have a charge plus 1. Oxygen minus 2. In this we have a charge minus 2. Aluminium 3 plus. Here we have a charge plus 3. So this is a real charge is present on the atom. For example, we will go with the water. So what is water? Example, water formula H2O. So H bond OH. So we know this oxygen is more electronegative than hydrogen. So oxygen electronegativity value is 3.0, hydrogen electronegativity value 3.2.1. Okay. So when bond is going to be breaking, so oxygen is going to be pulling towards more electron towards itself. So by that it is going to be attain partially negative charge on it. So by that partially negative charge on the what you can call oxygen atom, partially positive charge on the hydrogen atom. Similar, this bond also same way. Oxygen is going to be more electronegative. That's why electron pulls towards itself. So oxygen gets more electronegative. So oxygen get that partially negative, and oxygen will hydrogen will get partially positive. So in this, hydrogen will get plus 1 charge, oxygen will get minus 2 charge, and hydrogen will get plus 1 charge. So these are going to be have what you can call imaginary. For example, hydrogen and chlorine bond is there. In this, we have when bond break that, chlorine will get minus 1 charge, hydrogen will get plus 1 charge. Why? Because chlorine is more electronegative than hydrogen. So chlorine electronegativity value is 3.5 and hydrogen electronegativity value is 2.1. Hydrogen electronegativity value is 2.1. So this is the oxidation number definition. So let me go with the number of rules are present in this oxidation number. What are the number of rules? We will go with that. Okay. Take rule number 1. It is nothing but if you take any molecule, the sum of oxidation number of all the atoms present in the molecule is equal to 0. So the sum of oxidation number of all the atoms present in the molecule is equal to 0. For example, I am taking here sulfuric acid. Formula is H2SO4. If you see here, how many atoms are there? There are 7 atoms are present in this molecule. So there are 2 hydrogen atoms, 1 sulfur atom, 4 oxygen atoms. That means oxidation number of hydrogen into 2 times plus oxidation number of sulfur plus oxidation number of oxygen into 4 times is equal to 0. So this is about first rule. So let me go with one more example, simple example. I am taking carbon dioxide. That means oxidation number of carbon, there is only one carbon atom. So carbon into 1 plus oxidation number of oxygen into 2 is equal to 0. So this is about first. I hope that you are going to be clear this first rule. So let me move on to the second rule. Right. Rule number 2. Oxidation number of any atom in its elemental state is 0. For example, hydrogen is reacted with oxygen to form a water, right? In this, hydrogen is in elemental form, oxygen is also elemental form, but if you see this hydrogen and oxygen in this combined form, so they are in the molecule, so they are in the compound. So you see that hydrogen, oxygen, hydrogen, it is in the elemental form, so oxidation number is 0. Oxygen is elemental form, oxidation number is 0, but here it will not be equal to 0. Why? Because they are in the combined state. They are in the combined state, right? So here we have oxidation number of hydrogen is 0 because it is in the elemental state. Oxidation number of oxygen is 0 because it is an elemental state. Clear everyone? Right. So let me take one more example. C plus O2 gives that CO2. CO2. So in this particular example, carbon is elemental form, so its oxidation number is 0. Oxygen is also elemental form, its oxidation number is 0. But in this case, they are in combined state, so we cannot predict that it is a 0. So we are going to be calculate that one. So let me go with some more rules, then we can calculate this properly. Okay, right. So this is, I hope that you are going to be understand this rule number 2. So let me move on to the rule number 3. Right. Rule number 3. The oxidation number of alkali atoms or alkali metals in its in its combined state is plus 1. So do you know what will be alkali metals? Alkali metals are lithium, sodium, potassium, rubidium, cesium and francium will be there. So but for these elements, oxidation number is plus 1 in their combined state. In their combined state. Okay na? So how it will be see that? For example, I am taking here when sodium is reacted with the water, going to be form a sodium hydroxide along with the hydrogen gas. See this in this particular example, we are going to be talk about only alkali metal. See this, hydrogen is there, sorry, nitrogen, sodium is there. It is which state here? It is elemental state. So it will be 0. Well, because we are talking about elemental state. Second rule, what it's going to be tell us? In the second rule, the oxidation number of any atom in its elemental state is 0. See this, in this particular, sodium is in the combined state. So So we can go with the plus 1. So we are going to be have a sodium oxidation number is plus 1. Let me go with that. Lithium plus oxygen will go with that Li2O. So in this particular state, lithium is here, the left side it is in the elemental state, so it is become 0. In the right side it going to be have combined state lithium oxidation number is plus 1. There are two lithium atoms, so we can multiply with the 2. We can multiply with the 2. Clear everyone? So first rule it is going to be tell that the oxidation number of sorry the sum of all oxidation number of atoms will be equal to 0. So the oxidation number of all the atoms present in the molecule is equal to 0. Second rule will tell us the oxidation number of any atom in its elemental state is equal to 0. And also we can go with the third one, the oxidation number of alkali metals will be equal to plus 1 in their combined state. Okay, right. Let me move on to the third one completed, fourth one. Rule number 4. The oxidation number of alkaline earth metals is plus 2 in their combined state. Do you know what is the alkaline earth metals? Alkaline earth metals is beryllium, magnesium, calcium, strontium, barium and radium. So radium is radioactive element we cannot consider for oxidation state. Here we have this one, beryllium, magnesium, calcium and strontium and barium. So their oxidation number is plus 2 in the what you can call combined state. Let me go with an example. Magnesium plus oxygen gives that magnesium oxide. So in this particular example, left side magnesium is elemental form, so it become what? 0. Right side magnesium is in the combined state, so its oxidation number is 0, sorry plus 2. If you see that there are two atoms Mg and O, right? So magnesium oxidation number, oxidation oxygen oxidation number will combine will get a 0. We know according to fourth rule we know that oxidation number of magnesium is plus 2, then what is oxidation number is going to be, let it be x is equal to 0, x is equal to what? Minus 2. So in this particular oxygen will get hot oxidation number is minus 2. So like that we are going to be calculating. Clear? So let me complete all the rules, then we can go with some more examples how to calculate. Clear? Clear? So once again I am going to be repeat this. The oxidation number of alkaline earth metals is plus 2 in their combined state. So alkaline earth metals are beryllium, magnesium, calcium, strontium and barium. So here we have an example how we are going to be calculate. Clear everyone? Right. Let me move on to the fifth rule. Move on to the fifth rule. Rule number 5. Rule number 5. The oxidation number of hydrogen is plus 1 except except in its hydrates, except in its metal hydrates. Metal hydrates. See that I'm taking example here HCl. In this particular example, hydrogen is plus 1, hydrogen is plus 1 and chlorine is minus 1. Why? Because they are in combined. So when hydrogen oxidation number, chlorine oxidation number will be equal to, so hydrogen is plus 1. So obviously the chlorine oxidation number is will become minus 1. Clear everyone? Clear everyone? So in this particular example, H2SO4 will go with that. Oxidation number is hydrogen is how much? Plus 1. So there are how many hydrogen atoms? 2. So plus 1 into 2 we are going to be calculating like this. Right. So you are going to be telling one exception. Metal hydrides. What is called metal hydrides? When metal with hydrogen is going to be called metal hydride. Sodium hydride, magnesium hydride, aluminum hydride. So they are going to be called hydrides. In this particular session, we know that alkali metals are going to be combined state, they will be a plus 1. So plus 1 means obviously hydrogen become minus 1. In this also plus 2 means, so there are, so magnesium plus 2, hydrogen become minus 1. In this also aluminum plus 3, hydrogen become minus 1. So simply we can say that hydrogen always plus 1 except in its metal hydrides. In the metal hydrides it is going to be exhibit as minus 1. I hope that you are going to be clear this rule also. Rule number 5 completed. Then we'll move on to the rule number 6. Right. Next number rule. Rule number 6. Oxidation number of oxidation number of fluorine is always minus 1. Always minus 1. So fluorine always ఎలా ఉంటుందమ్మా మనకు minus 1 లోనే ఉంటుంది అనమాట. ఓకేనా? ఓకే రైట్. రూల్ నెంబర్ 7. If you see that oxidation number of oxygen, it can be variable from different states. Let me go with the one by one. In its oxides, it has minus 2. In its peroxides, it is minus 1. In its superoxides, it is minus 1 by 2. In its ozonides, it is minus 1 by 3. And in its oxyfluorides, it should be O2F2. If we take O2F2, it will be plus 1. If we take OF2, it is plus 2. So oxygen will exhibit a different oxidation state in a different manner. So in oxides, it will be exhibit that minus 2. In peroxides, it will be exhibit that minus 1. In a superoxides, it will be exhibit that minus 1 by 2. In the ozonides, it will be exhibit minus 1 by 3. In the oxyfluorides, in a OF2, it will be exhibit plus 2. In a O2F2, it will be exhibit plus 1. Okay, right. Let me move on to the next rule. Rule number 8. In a compound ion, in a compound ion, the sum of oxidation number of all the atoms is equal to its charge. For example, I am taking here phosphate ion PO4 3 minus. So there are five atoms are there, one phosphorus atom and four oxygen atoms. When we combine this oxidation number of atoms will be equal to, that means oxidation number of phosphorus and 4 times of oxidation number of oxygen is equal to minus 3. Let me go with the one more example, sulfate ion. So when we take this oxidation number of sulfur plus 4 into oxidation number of oxygen is equal to minus 2. Okay, so this is the rule number 8. Okay, so apart from that there are some more rules in advanced level. So we'll have one more rule of halogens. Halogens will exhibit halogens. Generally halogens will exhibit that. Halogens means what? Fluorine, chlorine, bromine, iodine, and these are going to be called halogens. Halogens are exhibited from -1 to +7, except fluorine. Fluorine already మనం చెప్పుకున్నాం. Fluorine will exhibit that always -1. Okay, and if you take about nitrogen, nitrogen is also going to be exhibit that from -3 to +5. So it is variable from nitrogen. So these are the oxidation number rules. So we are going to be learned all oxidation number rules what we have mainly important, and let me move on to the some problems and how to calculate the oxidation number, right? See that. Right. Find out oxidation number of Ki2. 1 minute. Let me go with that oxidation number of KMnO4. In this, calculate manganese. How we have to calculate? Let me go with the one by one rules. Rules we have to know first how to calculate oxidation number and all. First of all, we have to know the rules. Rule number 1. According to rule number 1, the sum of oxidation number of all the atoms present in a molecule is equal to 0. Right? See that. That means oxidation number of potassium plus oxidation number of manganese plus oxidation number of 4 times oxygen is oxidation number of oxygen into 4 times is equal to 0. We know that oxidation number of potassium, why? Because it is alkali metal, right? That is +1. We know that oxidation number of, we don't know, we have to calculate this, right? Plus let it be x, and oxidation number of oxygen is -2 in the oxides, that is equal to 0. That means +1 plus x minus 8 is equal to 0, x minus 7 is equal to 0, x is equal to +7, right? Let me go with the one more example. Oxidation number of, find oxidation number of chromium, Ka2, Cr2, chromium we have to calculate here. See that in this particular examples, potassium we know already, why? Because it is a alkali metal. Oxygen also we know that it is a -2, right? Let it go with that first rule. According to first rule, 2 times of potassium oxidation number plus 2 times of chromium oxidation number plus 7 times of oxidation number of oxygen is equal to 0. That means 2 into plus 1 plus, let it be, we have to calculate now, 2x. 7 into minus 2 is equal to 0. That means 2 plus 2x minus 14 is equal to 0. 2x minus 12 is equal to 0. 2x is equal to plus 12, and x is equal to plus 12 by 2. I hope that means x is equal to, finally we got it. This is the answer. How to calculate. I hope that you are going to be understand this concept. If you like the video, please do subscribe my channel. Thank you.